Hey, so this is the video where we look at confidence intervals for population mean using Excel. These are the steps that you're going to follow. We're going to get first the sample results. We're going to need the sample size n, the sample mean x, and the sample standard deviation. Now there are formulas to get this, or you can use the descriptive statistics in the toolbox if you have a PC. But I'm going to show you how to obtain these descriptive statistics using pivot tables. Once you have those, you can decide on the confidence level you need for that confidence interval, and you're going to obtain t, the critical value of t for your confidence interval, using the function t inverse. Once you have all these values, right, x, standard deviation, and t, you just use the formula. And just as a reminder, this is the formula for a confidence interval for a mean, where this part is the margin of error and tells you how far you may be from the population mean for the degree of confidence that you chose. Again, we're going to look at an example, and the research question here is, what is the average GPA for CHHS students? Again, this is a question about the population, the entire population of CHHS students. But we have sample data from a survey. But the research question is about the population, so we need to create a confidence interval for our estimate. We want to be 95% confident of our results. Okay? So first we're going to calculate the sample results. And you're going to do this from the data set. You're going to select the data and insert the pivot table. You're going to drag the variable of interest on the values box. Then you're going to right click on the numbers that appear on the table and click on value field settings. Once you're in the value field settings menu, you can choose the summarize by option you need to depending on what you need to calculate. You would choose average if you want to calculate the mean, or x bar. You would choose standard deviation if you want to calculate that standard deviation, and count if you want to calculate n, or the number of observations. Similarly, for the value of t that you need for your confidence interval, you will use a function called t inverse, where you would just plug in the probability that you want and the degrees of freedom. The probability that you plug in here depends on the confidence interval, on the confidence that you want. If you want to be 95% confident, you will choose 0.05 there. If you want to be 99% confidence, you would put 0.01 there. And for the degrees of freedom, those come from the sample size minus 1. This will save you the trouble of going to a t table. You can get the whatever you would get from a table, you can get from Excel using this function. But let's look at an example to make this more clear. We have our survey data here, and we have our GPA variable here, and we want to know the sample average for this GPA. Now you can use the average function of this, but I'm going to show you how to do this with pivot tables as well. So we will insert the pivot table, and I'm going to data and then a pivot table. Generally you would use a new worksheet, but in this case I have a place where I want to put that pivot table. I want to put it here and then click OK. Alright, there's our pivot table. Now I told you on my PowerPoint here, so once you insert the pivot table, drag the variable of interest into the values box. So I'm going to drag the variable of interest, GPA, here in the values box, or the values area for that matter. I prefer to use this little menu here. So boom, it gives us a table already. Now step 2 is to click on the numbers that appear on the table. and then click on value field settings. Okay, so I'm going to click exactly on the number there. So right click on my Mac, and then value field settings. And then summarize by, you can choose average if you want the mean. You can choose count if you want the, or count numbers. If you want the numbers that are in that in that variable, right? The non-missing values. So this will give you your n, and STDEV, that's the standard deviation of the variable. So let's start with average. So we're gonna get average and then click OK, and that gives us the average of that variable, of the variable GPA, right? 3.14. That is the sample average for the variable GPA, and I'm going to record it here. X bar is 3.14. Now I'm going to get, again, I'm clicking right there, I right click on the number, and I get these value field settings, and now I want the standard deviation for that variable, and click OK. The standard deviation is 0.56. And the sample size is given by all non-missing observations, right? So this will be all the numbers that we have there. So I'm going to right click on the number, field settings, summarize by count numbers. Give me how many non-missing values we have. And we have 47. The rest may be missing values, or they're not numbers. So n is 47. We know that the mean was calculated with these 47 observations, right? These were all the numbers, and the standard deviation as well. Now, the degrees of freedom, and this is in order to calculate t, right? The degrees of freedom will be given by, I'm going to make this bigger. The degrees of n minus 1 equals n minus 1, that's the degrees of freedom. We have 46. And t, that's the probability that we need to for our to obtain the t value, right? As I told you here, when you're using the t inverse, this probability is 0.05 when you want a 95% confidence interval, or 0.01 when you want a 99 confidence interval. The degrees of freedom, we already did that. They come from n minus 1. Okay, so in this case we want 0.05 because we want a 95% confidence interval. Now, in order to get the t value for these degrees of freedom and that probability, we just use the function t inverse. We put the probability in 0.05, comma, and the degrees of freedom, 46. And the t value is 2.01. 2.01. So now we have our sample mean, sample standard deviation, sample size, and t. We can go straight to the formula and start calculating that confidence interval. So this is the formula, just a reminder that this is the formula. So we're going to calculate first the square root of n, then get the standard deviation divided by that, then multiply this result by t. That will give us the margin of error. So let's go do that. The square root of n, this will be equal to SQRT of n, and it's 47. Then we'll divide the standard deviation by the square root of n. So this is equal to the standard deviation divided by the square root of n, which we just got here. Alright, now in order to get our margin of error, we need to multiply this by the value of t. So this is equal to t times the standard deviation divided by the square root of n This is our margin of error, 0.16. So in order to get the lower level of our confidence interval, we would just subtract this from the mean, sample mean, minus this, and equals to sample mean plus the margin of error to get the upper level of the confidence interval. So if you want to put it here, you know that you don't know where the actual population parameter is. You never will, but you are 95% sure that your sample size, your sample estimate is 0.16 from the population parameter. That is, you're 95% sure that the population GPA, average GPA, is between 2.98 and 3.3. That's how you would interpret it. We're 95% sure that the average GPA for CHHS students in the population is between 2.98 and 3.3. That's it. That's it for confidence intervals. So please go practice. I would suggest creating a confidence interval for the math variable and see what you get. Right. But and if you have any questions, please do not hesitate to ask me or Andy. Take care.